Hello everyone. In this video, we're going to be going over a BMAT past paper. I am taking only maths, physics, and chemistry at IB, of which chemistry is not my specialized topic, even though I do find it quite interesting. So in this paper, I'm going to be focusing on the maths and physics questions. I'm going to be skipping the biology and chemistry questions in this paper and attempting to teach you how to do at least the maths and physics portion of this paper as quickly as possible, because I've been told, and I can see from how the paper is written, that speed is definitely a focus of this paper. I will be doing this in a series of videos, as well as some engineering admissions assessment papers, which provide even harder maths and physics questions at the same level of speed pressure, perhaps a little less than the BMAT, over the few weeks leading up to the actual test date. So without further ado, I will get started on this paper, and the format will be that I do a question as fast as possible, and I'll let you know how long it took me, using my watch as a stopwatch here, and then I will explain to you the shortcuts involved in doing that question quickly in under a minute. So if you're new to the channel, this is Watch Me Do Math, and I make new videos every Tuesday, Thursday, and Sunday. And if this helps you, I hope you will subscribe and share with your friends. So let's begin. So this paper is provided courtesy of both Cambridge Admissions Assessment and taken from the physicsandmathstutor.com website, which is a great resource. Okay, biology question, skip. Chemistry question, skip. Below are 4 statements about electromagnetic waves. Microwaves, timing now. Microwaves have a smaller wavelength than visible light. False. Microwaves are less energetic, they are longer. Visible light is like this. The speed of visible light in a vacuum is higher than the speed of other types of electromagnetic wave. False. All electromagnetic waves move at the speed of light in a vacuum. Gamma rays have the largest wavelength. False. Highest energy, lowest wavelength. Radio waves are used in hospital radiography to look for broken bones. False. X-rays are used. Which of the statements is correct? None of them. Okay. So that question took 28 seconds, and it relies on a bit of background knowledge about physics, which is to say that as the waves get more energetic, as you move up the electromagnetic spectrum, you go from gamma rays, which are the most energetic, to radio waves, which are the least energetic. And visible light is somewhere here, and microwaves are between radio and visible light, and so on. The radio waves being used in hospital radiography are that sort of background knowledge that you would have to have, as this is a BMAT, as well as the fact that the application of X-rays to finding broken bones in hospital radiography is usually a part of most physics courses as well. So anyway, let's continue. Next question. Which one of the following is equivalent to root 5 minus 2 squared? Okay, immediately remember a squared minus 2ab plus b squared. Root 5 squared, 5. Minus 2, 2 times root 5 times 2, 4 root 5. 2 squared, 4. So it's 9 minus 4 root 5. And that was about 20 seconds. So for this, it's just simply recognizing that this is in the form a minus b squared. So square 5, 5. Square 2, 4. 5 times root 5 times 2 again is 4 root 5. And then just remember the minus and plus after you've done those 3 calculations. So your mental steps you'd want to look at root 5 and in your head immediately go 5. Look at 2 and immediately go 4. Look at the 2 and the 5 again, and then multiply by 2 again and immediately go 4 root 5. And then you look at the minus sign and go 5 plus 4 minus 4 root 5. So you do a squared plus b squared and then minus 2ab. That's a faster mental way to calculate it in my experience. So a plus or minus b squared, think of them as a squared plus b squared, and then you do the plus or minus 2ab at the end. So look at A, instantly go to A squared. Look at B, instantly go to B squared. Don't write anything down, don't think anything else. Just think of root 5 and then immediately think of 5. Think of 2 and immediately think of 4. Alright, now let's move to the next question. Inherited condition, okay, this is biology. This is chemistry. Okay, this is physics. A puddle is left on a road after a rain shower. Started timing already. The water in the puddle slowly disappears by evaporation. 3 statements about the effect of changing different conditions on this process are given below. The rate of evaporation is greater at higher temperatures. Yes, this is true. The rate of evaporation is greater when the air above the puddle is still. No, this is false because the water molecules would need to be blown away in order for more evaporation to occur. And 3, the rate of evaporation is greater when the puddle has a larger surface area. This is true. Okay, it's 1 and 3 only. So that took 29 seconds. What you want to remember, this is again a bit of a memorized content question, but the intuition comes from this. The rate of evaporation is greater at higher temperatures. Well, yes, it's greater when the air above the puddle is still. False, because if you have some puddle and you've got water molecules saturating the air above it, then it is less likely that water molecules will be blown off, basically. As well as the fact that still air is less likely to pick up water molecules from the surface of the liquid. Anyway, that's more of a physics explanation. And finally, the rate of evaporation is greater when the puddle has a larger surface area. Well, yes, because the more chances that a particular water molecule is given to lift off from the liquid, the faster it'll evaporate. So this is really just about reading the question as fast as you can and understanding the principles of evaporation. To think of this quickly, you may want to just like tick, cross, tick as you figure them out. Take them one at a time. Don't try and skip, because in this paper you can see there's 8 options, 2 to the power of 3 options, and so they want you to know every single one of these. So treat each of these like 1/3 mark questions. Anyway, next. In a group of 20 patients in a medical center, 5 suffer from migraines. 2 patients from the group of 20 were picked at random for the survey. Start timer. 2 patients from the group of 20 were picked at random for the survey on the use of painkillers. What is the probability that both the patients picked suffer from migraines? Okay, so if you have migraines, no migraines, survey, no survey, and you draw this thing called a contingency table, just quickly, and then this is your total 20. 5 suffer from migraines, 15 without migraines. 2 for a survey, 18 without a survey. So this is 2/20. You want both the patients picked suffered from migraines. You want this probability. So 2/20, 5/20 becomes 10/400. And that becomes 1/40. Ooh, hold on there. Okay, this was a tricky one, wasn't it? Let's think about this again. This contingency grid was the wrong strategy. It's now taken me more than a minute to do this, which is not so nice. So 1 in 4 have migraines. 1 in 10 were picked. But the thing is, this is not independent. There are it's like 5 people with migraines in the group, plus 15. So first it would be 1/20, and then the next probability, it would be 5/20, and the next probability is 4/19. And you'd want to realize that this 5 times 4 is 20, cancel these out, 1 over 19 immediately. So, although I didn't get that on the first try, my mistake was that I went straight to a contingency grid because usually that's fast for things like BMAT and so on, but that was the wrong strategy here. And you want to treat this like a drawing different colored balls out of a pot kind of problem. So if you had like 5 red balls and 15 blue balls in a pot, then use the same probability tree strategy to figure out the total probability of drawing out 2 red balls. Right? There's another way you can do this with like 5 choose 2 over 20 choose 2, but that's just a little over the top. So don't do that. 1 over 19 is the final answer here. Okay. So, yes, regrettably, did not finish that in 1 minute, but it's okay. Think of these kinds of problems as balls in an urn problem, or balls in a pot, balls in a goblet, however you'd like to think about it, and it becomes much easier. Okay, dialysis, biology. Magnesium ribbon, chemistry. Okay, resistors. 2 resistors, R1 and R2, are connected in series with the cell. Resistor 1 has twice the resistance of resistor R2. Okay, consider this. Start the clock. Consider this 1, consider this 2. Voltage across each resistor is the same. False. Okay, this takes 2/3, this takes 1/3. Voltage across R1 is twice that of R2. Correct. Voltage across R2 is twice that across R1. False. Current is the same in both resistors. Correct. Current in R1 is twice the current in R2. If 4 is correct, then 5 and 6 are automatically wrong. Don't even think about them. Okay, so it seems like that took about... Oh shit, we haven't even answered the question. Well, okay, let's continue. 2 and 4 only. C. 38 seconds. Plus a little bit, so maybe like 50 seconds. Anyway, it seems like to me, when they gave this 6 thing, I was going through all of them, but what you'd probably want to do is you could see that these 3 statements are all about the voltage, and once you realize that R1 is twice that of R2, just eliminate the other 2 because they're definitely not going to be right because they, like, 1, 2, and 3 exclude each other from being right. The same applies for 4, 5, and 6, because you saw how I realized 5 and 6 were just different versions of the thing being compared in 4, so I selected 4 as the right answer and immediately deleted 5 and 6 as being impossible to be correct. You may want to skim over them before you do this, but if you see something like this after you've already answered this kind of question, do not try and interpret it in a physics way in your head. Just compare it to the previous one, and if it's already been excluded by a previous answer you made, delete it. It's wrong. Save thinking in the physics framework for when you hit a new kind of question that is not invalidated by your previous answers. And for this, there are a couple things you need to remember. So the first thing was that current is conserved. And the second thing is that voltage is split between resistors. So if you imagine a fast-moving river going up a big hill 2 meters high, and then going up a little hill 1 meter high to become just a slow-moving river before falling down again through the battery. This is a river of electrons, by the way. The rate of flow of electrons in the river will be constant throughout the whole river, right? So that's why it's constant throughout both resistors. But it takes twice the amount of energy for the river to get up this hill than this hill, the bigger resistor. Because you remember, potential difference is unit of joules per unit charge, or joules per electron is also a possible unit. of potential difference. So if you think about it as in the energy required of each electron to go up this 2 meter hill / 2 ohm resistor versus this 1 meter hill / 1 ohm resistor, then it'll take twice as much energy, twice as much potential difference. Another way to think about it is think of a ball rolling down a hill. If the ball is up here, high potential. If the ball is down here, low potential. There is a potential difference that the ball has gone through. It's like the enthalpy change of the ball as it in terms of its gravitational potential energy. Or in other words, its potential difference, but this just applies to gravity. So you can think of electrons in this river model with the different mountains being different resistors and so on, before falling down the waterfall, which is the battery, giving them like however many joules of energy per electron, before flowing back uphill and releasing its energy, transforming its energy back to potential energy, right? Anyways, hopefully that made a little sense. The keys to speed, at least in this one, was realizing that you can eliminate other parts of this without even thinking about it in the physics perspective. Okay, let's move on. Start the clock. Triangle PRS line QT. QT, this one is parallel to RS. Okay, those are parallel. This is 1.5, this is 0.3. That's 1.8. That means X is here. So I immediately see that this is 1/5 of this. So that means X is 1/5 of the total. So that means this must be four parts if X is 1 part. It's a 1:4 ratio if this is 1/5, right? So X and 4X, never mind, 4X is 1.8. That means X is 0.45, or the length of PS is going to be 2.25 cm. So that's 40 seconds. The key here was realizing that because of this parallelism in the triangle, especially in geometry questions like this, you've got to notice when one shape is basically a multiple, quote-unquote multiple of another shape, right? This shape is going to have 1/5 the sides of this whole big shape here. So that means PT is like 1 part when PS is 5 parts. And it doesn't matter what the part is, you might use a variable like X, but anyway, if PT is 1/5 of the whole thing, that means this is 4/5 of the whole thing. But I don't think about it in terms of fifths. Think about it in terms of PT. And consider it like 1 unit. You gotta get used to thinking of arbitrary units in these kinds of geometry questions. Here, your arbitrary unit is 1 PT. A PS is 5 PTs. And don't even think about it in terms, like, don't say the letters PT in your head. Just go, this is 1, the whole thing is 5, that means 1.8 is 4. So if 1.8 is 4, well, 1 is 0.45, so 5 is 2.25. Okay? You might work through it faster if you skip talking about the units in your head, and this will lead you to the answer 2.25 cm quite quickly. So the key realization was that PQT is 1/5 of this triangle, basically. 1/25 in area, but 1/5 in side lengths. And so if you think of this piece of line as 1, then you knew that the whole horizontal line was 5. That means 1.8 centimeters was 4. For what? Doesn't matter. You're just trying to think through this as fast as you possibly can. So 1.8 is 4, or you'd say something in your head like 4 is 1.8, 1 is 0.45, 0.45 plus 1.8 is 2.25. And that's how you might do this question quickly. All right, let's move on to the next question. Okay, this is biology, chemistry, Okay, let's begin. Radium-238 physics question is a naturally occurring alpha emitter. It can be used in the manufacture of isotopes Thorium-39 during which it is bombarded by neutrons. Process of converting nucleus. Okay, so it's atomic numbers 92, 94. Okay, 23892 goes to 23994. It is bombarded by neutrons. Okay, so we want to go up in mass number by 1. That means it must absorb at least 1 neutron. So you might go to like 23992, or at some stage before this it'll be 23894, 23793. Anyway, I'm confusing myself there. It absorbs 1 neutron, 23992, and then beta decay just increases this number by 1. So 239, 1 beta, 23994. So this works, F works, but that was 1 minute and 11 seconds. How can we do this faster? Well, the key here is to realize that there are two beta decays, because you go up in atomic number by 2. The only way to go up in atomic number is through beta decays. So you're looking for 2 betas. That means A is immediately ruled out, B is immediately ruled out, C is immediately ruled out, and E is immediately ruled out. So now just the order of the absorptions are in question. And if you understand the basic concept behind beta decay, it occurs when there are too many neutrons for the number of protons. Then you might realize that the absorption of the neutron comes first, or simply because of background knowledge that uranium-238 does not undergo beta decay. The absorption of the neutron comes first, which makes the atomic nucleus more unstable to the point where it radiates away a beta particle. It emits a beta particle. So if the absorption of the neutron is first, then it should be F. Another way you can think about it is that okay, never mind. I thought I had an idea, but I didn't know how to phrase it. Okay, and another thing is that this is actually a pretty common reaction to think about. Uranium-238 and plutonium-239 are both common isotopes that might be asked of you to think about. So it may be useful to remember things like bottom number going up must involve beta, top number going up must involve the neutron, and top number going up causes the bottom number to go up, because it's not stable if the top number is too high, right? Like this is not really a teaching video, but I'm just trying my best to show how you can do these questions fast. Okay, so 1 minute 11 seconds, not actually too bad, but I don't know, such is this paper. Very, very fast. Okay, let's continue. Okay, more physics, start the clock. Acceleration due to gravity, the surface of the planet is given by g is gm of r squared, m and r the mass and radius. G is 10, g is this number, r is 6. What is m? Okay, so you want to solve for m, that means multiply both sides by r squared. G is equal to gm. M is gr squared over big G. Okay, what's that? That's 10 times 6 squared, 36. 10 to the 6 squared, 10 to the 12. G, 7 times 10 to the minus 11. Okay, so this becomes 10 to the 23. 1036 over 7, 360 over 7. Well, this is approximately 50. maybe 51. 51 times 10 to the 23, take 110 out of this and move it to the 10 to the 23, becomes 10 to the 24. 5 times 10 to the 24, A. Okay, so that took 57 seconds. First step was to realize that you wanted m to be the subject, so immediately times r squared divided by g. Writing both of these steps down may have been a mistake for me. What you should try to do in your head is see in your mind this r squared moving to the right, to the left side, and then see in your mind this g moving to the bottom here. Okay, denominators go to the top of the other side, numerators go to the bottom of the other side. They go like that. In it, and so on. So you may want to look at this and immediately gone, oh, m is gr squared over g. Then the next thing you saw was r squared, 6 times 10 to the 6 squared. So that's 36 times 10 to the 12. Do not keep it in scientific notation until the very end of your answer, because that will waste your time. You want first this g, regular g, times r squared, so 36 10 to the 12 over big G, so 7 and 10 to the minus 11. The first thing I did was multiply both sides by 1 over 10 to the what am I even saying? First thing I did was divide both sides by 10 to the minus 11. And that brings the bottom side to nothing, and that brings the top side to 10 to the 23, because 12 plus 11 is 23. So the way I handle that on my working is I cancel these out, and they go to, that's what this arrow is for, 10 to the 23. So you want to look at this 10 to the minus 11 and 10 to the 12, and just strike it through, write 10 to the 23. And then you want to notice that 36 divided by 7 is approximately 5, or 10 times 36 is 360, which divided by 7 is approximately 50. So I suppose the faster way to do it here would have been, since you can see this is one significant figure, in hindsight, the faster way to do it would be to think, you see 36 over 7, cancel it, 5. Okay, just write this arrow and write 5. Think in your head, 36 over 7, oh, approximately 5. And then times 10 again. So see this 10 go to the 10 to the 23, it becomes 10 to the 24. And there's your answer, 5 times 10 to the 24. So this method of like drawing arrows through things to cancel them to a new value or even a faster way you could do it is like A plus B plus C plus D. Say you're doing this kind of sum. One way that I write math when working very fast with it is when I'm adding something up and removing them from the terms that I'm summing up, I'd go like this, because both of these sum up to x, and C and D, both of these sum up to y. And I sum x and y, and they become z, for instance. And that's sort of a mental way of doing just one really simple step at a time really fast. So strike through, cancel it, and direct to a new value. Right. So let's keep moving. Human heart, biology, propanoic acid, chemistry. Okay. Swimming pool. Swimming pool is 10 meters wide. Draw 10. Loud sound is made in the water 2 meters from one wall, and the reflecting sounds are detected with the microphone placed next to the sound source. The reflection from the wall 8 meters away arrives that many after the 2 meters away. Okay, so just think 4 meters versus 16 meters. Difference is 12 meters. 12 meters in 0.01 seconds. That means the overall solution is 1200 meters per second. So that took about 30 seconds. The key here is to be able to visualize what's happening. So you have both a speaker and a microphone at this point. And fundamentally, it's saying that the difference in the length of the path that it takes from here to here, so say it moves 4 meters here and 16 meters here, you can tell that because it's 2 meters to this wall and 8 meters to this wall, right? So you immediately go, yes, small 4, big 16, big distance, small distance, right? And you deal with that in your head. So arrives after, that should instantly clue you into the fact that you're looking for a difference between distances. So 416, just think 416, difference 12. No need to say the word difference in your head, just think 416, 12. Okay, 12 meters, you're dealing with 12 meters. And then it's 0.01 seconds, 1/100th of a second. You should immediately think after 12 meters in 1/100 of a second, or 12 meters in 1/100th of a second. That means 112 meters in 1 second. Or, once you think in your head, 112 meters, you should go immediately to 1200 meters per second. So this is all about being able to draw the diagram really quickly, just a very, very rough sketch. So I saw the first piece of information, 10, and then I drew the 2 walls, I drew the microphone, right, 2, so that means distance is 4, distance 16, difference is 12, because I saw the 10 seconds after, or like 10 milliseconds after. And then I realized 12 meters, 0.01 seconds, they want a speed, so it's obviously 12 divided by 0.01, or 112s, 1200 meters per second. So again, this is about skipping. Don't say units in your mental steps. Just go as fast as you possibly can. Skip words that you might write in a proof or long answer, structured answer. Okay, next question. Express this as single algebraic fraction. Okay, this one are easiest because there's only one term at the bottom, so almost 2x minus 1 over x. Multiply out x minus 2x over 2x squared. Divide both sides by 1x, so that's 1 minus 2 over 2x minus 1 over 2x. And then plus 1 over x minus 1. Multiply out again. X minus 1 minus x minus 1 plus 2x over 2x, x minus 1. And then this becomes 1 minus x, so flip it around because there's a minus sign. 1 minus x plus 2x. Minus x plus 2x goes to plus x. So it becomes 1 plus x over 2x, x minus 1. 1 plus x over 2x, x minus 1, e, here. Okay, so again, I did that calculation thing where I saw 2 terms, and then I just went slice through it, and then I wrote the new thing on top. So like minus x minus 1, I go slice 1 minus 1 minus x, because minus flips it around. It reverses the direction of the minus, right? And then the other thing was I chose to work with these 2 first because they're the fastest to work with. They get your brain in the mathematical mode, and at the same time they're the simplest, so it makes the rest of the calculation easier, right? So this becomes minus 1 over 2x since these 2 are going to result in the most simple thing. If you did do 1 over x minus 1 minus 1 over x, then you would have gotten like x minus 1 over x minus 1, right? And then this becomes just a 1 over x minus 1, which is all right, but it's a little harder to deal with because you then need to add this to 1 over 2x, which is annoying. And so finally you come to this result of 1 plus x over 2x, x minus 1 with the calculation tricks that I talked about, and there's your final answer. Okay, now let's keep going. Let's keep going. It's 27 questions. We can do this. Let's go to the end of the paper. Okay, inheritance biology, chemistry. Okay, 23. Book rests on a table. The book is a block. We're approximating here, which in turn rests on the floor. Floor exerts a force P on the table. Okay, so the table is experiencing a force P. This is normal reaction force. Force P and one other force. Okay, weight of the table. So the weight of the table is going to be the force that the Earth exerts on the table. Cool, got it. So, wait, hold up. This is really hard because there's really no shortcut to this. You just need to you need to have a perfect understanding of it. It's either this or this. The floor exerts that force P on the table but the P if you think about it, the entire weight of these two bodies is being sent into the ground, sent into the earth. However, because there's a weight from here into the table, that means there's also a weight. The effect of the book on the earth is also being pulled into the table, and overall it doesn't do anything to the table. So D would actually be correct because the force of the book on the earth and vice versa is already accounted for. And the table has a reaction force for each, right? And so the only thing left is the forces between the table and the earth. And given that P is one of them, the other of them must be the force of the table down on the earth. So I'm pretty convinced it's D, but honestly, no, I don't know any speed tricks there. It's just a question that you may need to think about before you get. I would say that if you come across this question in an exam and you are someone who does not understand Newton's third law of force pairs, skip this question, do not look back. The mark is not worth it. It'll take you at least 2 or 3 minutes. Okay? Because that already took me like 1.5 minutes to do. So, okay, let's go on 4 more questions until the end of this paper. Maths question, start the clock. Diagram shows a shape made of quarter circle radius 60 and right hand triangle. Blah. Okay, which of the following expressions gives the area of the shape? 6, 9. So this is pi r squared over 4, so it's pi 36 over 4, or 9 pi. This 9 pi, semicircle's 9 pi. This thing is, how do we do it? Well, the ratio is 3, 2, so this means this is going to be root 5, because this square is 9, this square is 4, and this square is going to be 5. So root 5 times 3, because the whole thing is scaled up by 3. 6 times 3 root 5 divided by 2 as half BH. 6, 2 cancel out to 3. 3 times 3 root 5, 9 root 5. Okay, so 9 pi plus 9 root 5, 9 pi plus, whatever, 9 pi plus pi plus 9 root 5. Here you go. So the first thing to realize is do the semicircle first because it's easier. It's just pi r squared and then divide by 4. R, 6, r squared, 36. Divide by 4, 9. And area 9 pi. So you should think, oh yeah, semicircle, divide by 4. 6, 36, 36 pi, 9 pi. That should be your mental thought process. And then the triangle, you should go IS, Pythagoras. But don't do 9 squared minus 6 squared square rooted, because that's a little bit long-winded. What you want to do is realize that this is 3 times a different triangle which has simpler numbers. So it's a 3, 2 triangle. And with this information, you want to do something like, right, 3, 2, 3, 9, 2, 4. You're squaring the numbers because you want to use Pythagoras' theorem. 9 minus 4, 5. 5, root 5. That means root 5 is the bottom here, because you want to go 3, 9, square that, 2, 4, square that. 9 minus 4, find the square of the other side, square root, root 5. And then you scale up. So you go 6 and 3 root 5. And Or alternatively, you find the area of this, 2, and root 5 goes to just root 5. And then the area is multiplied by 9, 9 root 5. But anyway, you do the same sort of calculation trick. You swipe through 2 numbers and then write the answer to the side when you're doing one simplification instead of rewriting again and again. And you finally get your 9 pi plus 9 root 5 answer, C. Okay, let's keep going. Siamese cat. Okay, this had me confused, but this is a biology question. Chemistry question. Finally, physics question, kinetic energy. Let's begin. Graph of kinetic energy against the square of the speed is plotted. Okay, so v squared ke. K is half mv squared, that means k is proportional to v squared, that means it's going to look like this. So if it's half mv squared, that means the gradient is half m because v squared is equal to x. So half m, 2.5 over 2, 1.25. Pretty easy. Nice and easy question to finish the test. And what you want to do here is realize that because you have this EK is half mv squared, just think of it like y is equal to mx. In your mind, you should visualize EK coming off as y, v squared coming off as x, and they just float away from the equation. And you're left with this gradient half m, which you can easily calculate from the value of 2.5. So my advice for this question, remember the formula, and you want it in terms of y is mx. So imagine the y term and the x term just floating away, and you're left with the gradient. Not very scientific, but it works to visualize. It works in visualizing. So anyway, that's all I have to say for this paper. This fairly cool BMAT Biomedical Admissions Test, Section 2 for 2017. So until next time, thank you for watching.